morning, everyone. Thank you for joining. I've been invited by Zappletech to host this little event today. It's a nice little test meetup talking about automation. Got a couple of pretty cool speakers today, but Andrew Knight, he's going to talk about the Screenplay pattern, which is done by Serenity JS. Got a little experience using that framework. It's a pretty cool concept, so I'm really interested to hear some real-world applications of that. We've also got Matthias Zax. He's going to talk about security testing. This is an area that quite a few people don't get the benefit of having experience in. So it's going to be really interesting to see how he's using this in a day-to-day, in the day-to-day life of a tester. A little bit about myself. I've worked as a developer, also tester for about 17 years in software. I've worked in many small and large companies across all kinds of different industries and most every language you could think of. So this was a really interesting event to be invited to. I'm really happy to be hosting and kind of moderating things along today. And if you have any questions for me, go ahead and put them in the chat and we can get to those when that time comes, as well as with the speakers. If you have questions for them while they're speaking, please put them in the chat and the moderator will help to move that along at that time. So at this point, I just wanted to give that quick intro about myself and about the speakers and open it up if anybody has any questions for me. Hey, good morning. I'm in Maine, so Philip Day down in South Florida. It's a little nicer where you are, I'm sure. Morning, Anna. So the first topic is going to be about Screenplay. We've got a little bit of time before. So what is Screenplay? Screenplay is pretty interesting. I did a little bit of POCs on that at a prior company. We didn't end up having time to use it, but it's a pretty cool concept of, if you think about a play or a movie, you have actors, you have a stage, different things that happen. And I found it very interesting to see this kind of revolutionary concept, piggybacks off of as well a lot of Cucumber BDD concepts that you guys might have had experience with. So that's pretty cool. The next one we have is about security. I personally have never had the opportunity to do full-on real security testing, things like using OWASP tools and true penetration testing. That's something that I, as a test manager, look for that skill set when I'm trying to build out a team, especially for a SaaS-based web app. The world we live in today, we're getting hit by constant attacks, constant zero-day vulnerabilities that are coming out that, aren't attacks, but they're things that have found in code. We recently had, as you probably all are aware, a major vulnerability in the log4j library. That's something that most everyone that uses Java was using for logging. So you can see that was very pervasive across the entire industry. And his type of testing is very, very important. It doesn't get the attention that it should a lot. It doesn't get the budget and the prioritization it should a lot, because security isn't something sexy that people want to talk about. So I'm really looking forward to what he has to say. Got about 7 more minutes. Speakers are making their way in, trying to get their systems up and running, getting everything working. So just give them a few more minutes to make sure they're prepared and ready to share their screens and ready to go. We have one speaker that just spoke up. Andrew, our first speaker, he is ready to go. So if everyone doesn't object, I think we can get started a little bit early. Hey, I can see him now. Hey, Andrew, how are you? Goes by the Automation Panda, so I think his name is Pandy on here. Assuming that's where that came from. How you doing?
Doing well. How are you, Chris?
I can't complain. Nobody listens anyway, right? Sorry to make you spit your coffee.
Ouch. Actually, I drink tea because coffee gives me the jitters.
It gives me the jitters too. That's why I cut myself off before lunch.
Oh gosh, it gives me jitters. It gives me headaches. I am team tea all the way. I like
Nice.
hot tea, sweet tea. I'm from the South in America, so
Oh yeah,
sweet
you
tea
have to have
everywhere.
sweet tea. The more sugar, the
Yep.
better.
Dude, I went to a conference in the South one time, and I went to the sweet tea cooler, and I got some sweet tea, and it was
Yeah.
unsweet. I don't know what happened. It was horrible. The sin.
Somebody missed the memo, I think.
Yeah,
Sweet
exactly.
tea is supposed to be sweet. You're supposed to have about 3 pounds of sugar in it, and then get diabetes when you're done, I believe.
That's right. And you can't just have like cold iced tea and add a sugar pack to it. You need to boil the tea and add the sugar while it's hot because it super saturates.
You got to caramelize that sugar in there. That's right.
That's right.
So
That's right.
if you are ready, I think people have heard enough about our terrible euphemisms. If you're ready to go,
Let's roll.
All right. Thanks a lot. I'll hand it over to you.
Okay. Hello, everyone. Thanks for attending my talk today, and thank you to Zappletech for inviting me as a speaker. I'm super excited to be here. So my name is Andrew Knight, but you may know me as Pandy for short. I am the Automation Panda. Be sure to read my blog and follow me on Twitter at Automation Panda. For my day job, I am a developer advocate at a company called Applitools. If you haven't heard of Applitools, they provide visual testing tools to help your app look visually perfect. Pretty cool stuff. I also lead Test Automation University, which is one of the best platforms for upping your testing and automation skills. We offer about 70 courses completely for free from some of the best instructors in the world on all sorts of testing and automation topics. So real quick, if you're new to visual testing and what Applitools does, here's a quick way to show you what it's all about. Side by side here are two pictures of an octopus garden. Can you spot the differences between them? Take a moment and see how many you can count. Do, 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 do. Give a few more seconds here for you to try to spot them all. It's like we're kids again, right? Fun times. Five, four, three, two, one. Boop. All right. Voila. There are a total of 10 differences between these pictures. Did you catch them all? Put in the chat how many you found. This here is the power of visual AI. It can detect any visual differences between snapshots in a split second without tripping over things like small pixel shifts. Applitools developed visual AI to help you automatically detect visual changes in your web apps, your mobile apps, and frankly, any other apps you develop. You can add visual snapshots to your automated tests to catch visual bugs. So that way, anytime your app changes over time, you can pinpoint the root of the problem. I always like to say if a picture is worth 1,000 words, then a snapshot's worth 1,000 assertions. So in a nutshell, that's what we do at Applitools. So visual testing is awesome and all, but that's not what I'm here to specifically talk about today. Just want to give a little background on what I do and what my company does. What I am going to talk about today is the Screenplay pattern, which is a new way to automate your interactions. Now, Screenplay pattern isn't exactly new. It's been around for a few years, but it's still new to a lot of folks in our industry. I strongly believe that Screenplay is a much better way to interact with web pages than, say, page objects. I believe in Screenplay so much that I developed Boa Constrictor, the .NET Screenplay pattern. So in this talk, I'll introduce the Screenplay pattern in 3 parts. First, I'll cover problems with traditional ways of automating interactions. Second, I'll explain why the Screenplay pattern is a better way. And third, I'll show how to use Screenplay pattern with a C# library named Boa Constrictor. So to start, let's define that big I word I was tossing around. Interactions. Simply put, interactions are how users operate software. For this talk, I'll focus on web UI interactions, like clicking buttons and scraping text. Interactions are indispensable to testing. The simplest way to define testing is interaction plus verification. That's it. You do something and you make sure it works. Think about any functional test case that you've ever written or executed. The test case was a step-by-step procedure in which each step had interactions and verifications. Here's an example of a simple DuckDuckGo search test. DuckDuckGo, if you're not familiar with it, is a search engine like Google or Yahoo. The steps here are pretty straightforward. Opening the search engine requires navigation. Searching for a phrase, pardon me, searching for a phrase requires entering keystrokes and clicking the search button. Verifying results requires scraping the page title and result links from the new page. As you can see, interactions are just everywhere. Unfortunately, though, our industry struggles to handle automated web UI interactions well. Even though most teams use Selenium WebDriver in their test automation, every team seems to use it differently. There's lots of duplicate code and flakiness. So let's look at the way many teams evolve their WebDriver-based interactions. I'm going to use C# for code examples, and we'll continue that DuckDuckGo test case. When teams first start writing test automation code using Selenium WebDriver, they frequently write raw calls. Anyone familiar with the WebDriver API should recognize the calls I'm about to show. WebDriver object is initialized using, let's say, Chrome driver, if we're testing Chrome. The first step to open the search engine calls driver.navigate.goToURL with that DuckDuckGo website address. The second step performs the search by fetching web elements using driver.findElement. It has some locators there, and then it calls methods like sendKeys and click. The third step uses assertions to verify the content of the page title and the existence of result links. Finally, at the end of the test, the WebDriver quits the browser for a proper cleanup. Like I said, these are all fairly common WebDriver calls. Unfortunately, though, there's a big problem here. Race conditions. Bum, bum, bum. There are no less than 3 race conditions in this code, in which the automation does not wait for the page to be ready before making the interaction. WebDriver does not automatically wait for elements to load or for titles to appear. You've got to do that on your own. Waiting is a huge challenge for web UI automation, and it's one of the main reasons for what we call quote-unquote flaky tests. You could set an implicit wait that will make calls wait until the target elements appear, but they don't work for all cases, such as the title in race condition number 2. Explicit waits provide much more control over waiting, timeout, and conditions. They use a WebDriver wait object with a preset timeout value, and they must be placed explicitly throughout the code. Here, they are placed in the 3 spots where race conditions could happen. Each wait.until call takes in a function and returns true when the condition is satisfied. These waits are necessary, but they cause new problems. First, they cause duplicate code because web element locators are used multiple times. Notice here how search form input homepage is specified twice. Ugh. Second, raw calls with explicit waits make code less intuitive. If I remove the comments from each paragraph of code, what's left is a wall of text. It is difficult to understand what this code does at a glance. To remedy these problems, most teams use the page object pattern. In the page object pattern, each page is modeled as a class with locator variables and interaction methods. So, a search page class could look like this. At the top, there could be a constant for the page URL and variables for the search input and search button locators. Notice how each has an intuitive name. Next, there could be a variable to hold the WebDriver reference. This reference would come via dependency injection through the constructor. The first method would be a load method that navigates the browser to the page's URL. And the second method would be a search method that waits for elements to appear, enters the phrase into the input field, and then clicks the search button. This page object class has a decent structure and a mild separation of concerns. Locators and interactions all have meaningful names. Page objects require a few more lines of code than raw calls at first, but their parts can easily be reused. The original test steps can be rewritten using this new search page class. Notice how much cleaner this code looks. The other steps can be rewritten using page objects too. Unfortunately, page objects themselves suffer problems with duplication in their interaction methods. Suppose a page object needed a method to click an element. We already know the logic. Wait for the element to exist and then click it. But what about clicking another element? The method is essentially hard-coded for one button. A second click method would be needed to click the other button. Unfortunately, the code for both methods is practically the same. And the code would be the same for any other method we'd want to have for clicks. This is copy pasta, and it happens all the time in page objects. I've seen page objects grow to be thousands of lines long due to duplicative methods like this. No lie. Tens of thousands of lines even. At this point, some teams will say, oh, hold on, wait a minute. You got more duplicate code? We can solve that problem with some more object-oriented programming. And they'll create the infamous base page, a parent class for all other page object classes. The base page will have variables for the WebDriver and the wait object. It'll also provide common interaction methods, such as this click method that can click on any element. Abstraction for the win, right? Child pages will inherit everything from the base page. Child page interaction methods frequently just called base page methods. I've seen many teams stop here and say, haha, this is good, right? In my opinion, though, this still isn't very good. The base page helps mitigate code duplication, but it doesn't solve its root cause. Page objects inherently combine two separate concerns: page structure and interactions. Interactions are often generic enough to be used on any web element. Coupling interaction code with specific locators or pages forces testers to add new page object methods for every type of interaction needed for an element. Every element could potentially need a click, to scrape text, to check if it's displayed, or any other type of WebDriver interaction. That's a lot of extra code that shouldn't be necessary. Base page also becomes very top-heavy as testers add more and more code to share. More frustratingly, the page object code I showed here is merely one kind of implementation. What do your page objects look like? I bet dollars to donuts they look different than the ones I just showed. Page objects are completely freeform. Every team implements them differently. There's no official version of the page object compat. There's no conformity in its design. Even worse, within its design, there's almost no way for the pattern to enforce good practices. That's why you see people arguing over whether page object locators should be public or private, or how long they should be, or things like that. Page objects would be better described as a convention rather than a true design pattern. Yeah. There must be a better way to handle interactions. Thankfully, there is. Let's take a closer look at how interactions happen. First, there is someone who initiates the interactions. Usually, this is a user. They are the ones making the clicks and taking the scrapes. Let's call them the actor. Second, there is the product under test. For our examples in this talk, that's a web app. It has pages with elements. Web page structure is modeled using locators to access page elements from the DOM. Keep in mind, though, the thing under test could be anything else. It could be a mobile app, could be a microservice, or even a command line app. Third, there are the interactions themselves. For web apps, they could be simple clicks and keystrokes, or they could be more complex interactions, such as logging into the app or searching for a phrase. Each interaction will do the same type of operation on whatever target page or element it's given. Finally, there are the objects that enable actors to perform certain interactions. For example, browser interactions need a tool like Selenium WebDriver to make clicks and take those scrapes. Let's call these things abilities. Actors, abilities, and interactions are each different types of concerns. We could summarize their relationship in one line. Actors use abilities to perform interactions. Actors use abilities to perform interactions. This is the heart of the Screenplay pattern. In the page object convention, page objects become messy because concerns are all combined. The Screenplay pattern separates concerns from maximal reusability and scalability. So, let's learn how to screenplay using Boa Constrictor. Boa Constrictor is an open source C# implementation of the Screenplay pattern that my former team and I developed at Precision Lender. It is the cornerstone of Precision Lender's end-to-end test automation solution to this day. It can be used with any .NET test framework like SpecFlow or NUnit. The project has rich documentation hosted using GitHub Pages. The GitHub repository name is q2ebanking/Boa Constrictor. And the NuGet package name is capital boa.constrictor. Let's rewrite that DuckDuckGo search test from before using Boa Constrictor. As you watch this talk, I recommend just reading along with the code as it appears on the screen to get the concepts. If you're trying to code along in real time, it might be challenging. But after this talk, if you take the official Boa Constrictor tutorial, you can get hands-on with all the code I'm going to share today. To use Boa Constrictor, you'll need to install pardon me. You need to install a couple packages: Boa Constrictor, REST Sharp, and Selenium WebDriver, all from NuGet. My code example will also use Fluent assertions and Chrome driver. Let's begin. It all starts with the actor. The actor is the entity that initiates interactions. All Screenplay calls start with the actor, and most test cases need only one actor. The actor class optionally takes two arguments. First argument is a name, which can help describe who the actor is. The name will appear in logged messages. Second argument is a logger, which will send log messages from Screenplay calls to a target destination. Loggers must implement Boa Constrictor's iLogger interface. Console logger is a class that will log messages to the system console. You can define your own custom loggers by implementing iLogger. Abilities enable actors to initiate interactions. For example, an actor needs a Selenium WebDriver instance to click elements on a web page. Read this line in plain English. The actor can browse the web with a new Chrome driver. Boa Constrictor's Fluent-like syntax makes its call chains very readable. Actor.can adds an ability to an actor. Browse the web is an ability that enables actors to perform WebUI interactions. Browse the web.with provides the WebDriver object that the actor will use, which in this case is a new Chrome driver object. Boa Constrictor supports all browser types. Before the actor can call any WebDriver-based interactions, the web pages under test need models. These models should be static classes that include locators for elements on the page, and possibly extra things like page URLs. Page classes should only model structure. They should not include any interaction logic. Remember, separate your concerns. That way, interactions can target any elements, maximizing code reusability. Interactions like clicks and scrapes work the same regardless of the target elements. Search page class here has two members. First is a URL string, and the second is a locator for the search input element named search input. Locator has two parts. First part is a plain language description that will be used for logging. Second, it has a query that is used to find the element on the page. You might also call that the selector. Boa Constrictor uses WebDrivers by queries. For convenience, locators may be constructed using a statically imported L method. Less text, more fun. With our page in hand, let's look at the interactions themselves next. Screenplay pattern has two types of interactions. First is called a task. A task performs actions without returning a value, just does something. Examples of tasks include clicking an element, refreshing the browser, and loading a page. They all do rather than get. Boa Constrictor provides a task named navigate for loading a web page using a target URL, shown here. Read this line in plain English. The actor attempts to navigate to the URL for the search page. Again, Boa Constrictor's fluent-like syntax is very readable. Clearly, this line going to load the DuckDuckGo search page. Actor.attempts to is what calls a task. All tasks must implement the iTask interface. When the actor calls, when the actor calls attempts to on a task, it calls the task's perform as method. Navigate is the name of the task, and .to URL provides the target URL. The navigate task's perform as method is where the magic happens. It fetches the WebDriver object from the actor's ability, that's that dependency injection happening, and it uses it to load the given URL using a Selenium WebDriver call. As we remember, search page.url is the URL for our target page. We simply put it in the page class just to make it universally available. In the real world solution, you probably want to put that in like a config file or something. Those are tasks. Let's look at the second type of interaction. It's called a question. A question returns an answer after performing actions. Examples of questions include getting an element's text, location, and appearance. Each of these interactions returns some sort of value. Boa Constrictor provides a question named value attribute that gets the value of the text currently inside an input field. Read this line in plain English. The actor asking for the value attribute of the search page's search input element should be empty. Actor.asking_for is what calls the question. It's kind of like attempts to, but asking for because you now have a question. All questions must implement the iQuestion interface. When actor calls asking for or the equivalent asks for method, it calls the question's request as method. Value attribute is the name of our question here, and .of provides the target web elements locator. Value attribute's request as method, again, is where the magic happens. It fetches the WebDriver object, waits for the target element to exist on the page, and scrapes and returns its attribute, value. Search page.search input was that locator for the target element from before. Finally, once the value is obtained, the test must make an assertion on it. Should be empty is a fluent assertion that verifies that the search input field is empty when the page is first loaded. Test case's next step is to enter a search phrase. Doing this requires two interactions. typing the phrase into the search input, and clicking the search button. However, since searching is such a common operation, we can create a custom interaction for search by composing two lower-level interactions together. The search DuckDuckGo task takes in a search phrase. Its perform as method simply calls two other interactions, send keys and click. Using one task to combine these lower-level interactions makes the test code more readable and understandable. It also improves automation reusability. Read this line in plain English now. The actor attempts to search the DuckDuckGo for panda. That's concise and intuitive. The last test step should verify that the result links appear after entering a search phrase. Unfortunately, as we remember, this step has a race condition. The result page takes a few seconds to load and display those result links. Automation must wait for those links to appear. Checking too early will make the test case fail. Thankfully, boa constrictor makes waiting easy. Read this line in plain English. The actor waits until the appearance of result page links is equal to true. In simpler terms, wait for the result links to appear. Waits until is a special method. It will repeatedly call a question until the answer meets a given condition. For this step, the question is the appearance of result links on the result page. Before links are loaded, the question will return false. Once links appear, it will return true. The condition for waiting is for the answer value to become true. Boa constrictor provides several conditions out of the box, such as equality, mathematical comparisons, and even string matching. You can also implement custom conditions by implementing the iCondition interface. Waiting is smart. It will repeatedly ask the question until the answer is met, and then it will move on. This makes waiting much more efficient than hard sleeps. If the answer does not meet the condition within the timeout, then the wait will raise an exception. The timeout defaults to 30 seconds, but it can be overridden. Many of boa constrictor's WebDriver-based interactions already handle waiting. Anything that uses a target element, like a click or sending keys or scraping text, will wait for the element to exist before attempting the operation. We saw this in some of the previous example code. However, there are times when explicit waits are needed, like here. Interactions that query appearance or existence do not automatically wait. The final step is to quit the browser. Boa constrictor's quit WebDriver task does just that. If you don't quit the browser, then it will remain open and turn into a zombie. Always, always quit the browser. Furthermore, in whatever test framework you use, put the steps to quit the browser in a cleanup or teardown routine so that it is called even when the test fails. And there we have our completed test using boa constrictor's Screenplay pattern. All the separated concerns come together beautifully to handle interactions in a much better way. Screenplay pattern can be used for more than web UI interactions. Boa constrictor has interactions for REST APIs using REST Sharp as well. Let's quickly step through a REST API test. The actor is the same as before. To call REST APIs, the actor needs an ability named call REST API. It uses a REST Sharp REST client with a base URL. For this test, we will use a public API called dog API, which returns random pictures of cute dogs. One actor can have multiple abilities as long as each ability has a different type. Boa constrictor uses REST Sharp's REST request objects directly, which specify things like resource path and HTTP method. To call the REST API, boa constrictor uses this call. The actor calls the REST request. using that given request object. We can then check the response object for response code and other data. This test is quite basic, but Boa Constrictor can do some advanced tricks, such as downloading files, dumping responses, and automatically deserializing response bodies. REST API interactions may also be composed with Web UI interactions. As we said before, the Screenplay pattern can be summed up in one line. Actors use abilities to perform interactions. It's that simple. Actors use abilities to perform interactions. For those who like object-oriented programming, the Screenplay pattern can be seen, in a sense, as a solid refactoring of the page object convention. Solid refers to 5 design principles for maintainability and extensibility: single responsibility, open closed, list-golf substitution, interface segregation, and dependency inversion. Now, I won't go into detail about each of these principles because that information is pretty dense. But if you're interested, take a quick snapshot of this table here and check out each of these principles later. Wikipedia is actually a pretty good source. You'll find that the Screenplay pattern follows each of these quite nicely. So, why should you use the Screenplay pattern over page object convention or raw WebDriver calls? There's a few key reasons. First, the Screenplay pattern, and specifically Boa Constrictor, provide rich, reusable, reliable interactions out of the box. Boa Constrictor already has tasks and questions for every type of WebDriver-based interaction. Each one is battle-hardened and safe. Second, Screenplay interactions are composable. Like we saw with searching for a phrase, you can easily combine interactions. This makes code easier to use and reuse, and it avoids lots of duplication. Third, the Screenplay pattern makes waiting easy using existing questions and conditions. Waiting is one of the toughest parts of black box automation. Fourth, Screenplay calls are readable and understandable. They use a fluent-like syntax that reads more like prose than code. Finally, the Screenplay pattern, at its core, is a design pattern for any type of interaction. In this talk, I showed how to use it for Web UI interactions, and I briefly teased REST API interactions. But you could use it for anything, such as mobile apps, command line, other APIs, all because you can make your own interactions. It's completely customizable. Overall, the Screenplay pattern provides better interactions for better automation. That's the point. This isn't just another Selenium WebDriver wrapper. It's not just to do spin on page objects. Screenplay is a great way to exercise any feature behaviors under test. And as we saw before, Screenplay pattern isn't that complicated. Actors use abilities to perform interactions. That's it. The programming behind it just has some nifty dependency injection. If you'd like to start using Screenplay pattern for your test automation, there are a few ways to get started. If you're programming in C#, you can use Boa Constrictor, the library I showed in these examples. If you're programming in Java or JavaScript, you can use Serenity BDD, a mature, complete test automation framework that includes the Screenplay pattern. Serenity BDD greatly influenced Boa Constrictor, but the two are entirely separate projects. Boa Constrictor is not Serenity BDD for .NET. Instead, Boa Constrictor aims to be a simpler, standalone implementation of Screenplay. If you're programming in Python, then hold on to your seats. Python is personally my favorite language, and I think it's one of the best languages for test automation. In my spare time, I've been developing a Screenplay implementation in Python. It'll be like boa constrictor, but the code will be even simpler because it's Python. None of these options suit you, then you could create your own. Screenplay pattern does require a bit of boilerplate code, but it's worthwhile in the end. And if you wanted to make your own, you can always reference code from boa constrictor and Serenity BDD because our projects are open source. If you want to learn more about boa constrictor, please visit the doc site. It provides thorough information about the project and the Screenplay pattern. I recommend taking the hands-on tutorial so you can develop a test automation project yourself with boa constrictor. It covers both the web UI and REST API interactions we saw today. Also, since boa constrictor is open source, the team and I would love for you to contribute. So thank you so very much for taking the time to learn more about Screenplay and boa constrictor with me today. Again, my name is Andy Knight, and I'm the Automation Panda, as well as developer advocate at Apple Tools. Be sure to read my blog, follow me on Twitter, and reach out to me if you'd like to join the boa constrictor project. Thank you.
Thanks, Andy. That was a really good in-depth. You covered a ton of information. Completely agree with you on your assessment of Python. I really think that most modern frameworks that I've seen, tend to be fairly close to what the app itself is being written in, just for one, for ease of use of everyone's already got their head around that tech stack, and also convincing developers to contribute to the test framework, right? That's the big win. So I think it's really between Python and JavaScript today. Those are the two big key technology stacks that are, interchangeable. I mean, once you learn the syntax of one, you can figure out the other one, and it's really simple. So completely agree. I'm not sure if there's questions that are waiting. I don't see any from the moderator at this point. I'll just give people a couple minutes in case they have questions for you or want to ask you anything directly.
Sure. I mean, ask me anything, whether it's Screenplay, boa constrictor, Python, testing, software. Ask me about my cars. Ask me about my puppy, whatever.
I'm interested to hear a little bit more about what you're going into with Python and what direction you're going with Screenplay with that, because it's really prescriptive. Screenplay itself, if you read the stuff from, I think it's Ferguson Smart, John Ferguson Smart that does that. It's pretty prescriptive about what he likes to use, but I think it's cool that you're coming up with your own wrapper for that. So could you talk a little bit more about that maybe?
Sure. So actually, I'd like to first chat a little bit more broadly about my vision and approach to Screenplay, and then I can talk about Python.
Yeah, that's exactly what I meant. Thank you.
Sure. So a little bit of backstory. When I joined Precision Lender back in April of 2018, that was my previous company, I was hired to be their first software engineer in test. They didn't have any test automation beyond some unit tests. They didn't know how to go about building a high-scale test automation project. Like, it was all new to them. So when I came in, they're like, Andy, keys to the kingdom, go, make it happen. I'm like, oh, okay, this is really cool, And so I basically built up that project. I called it BOA because of tongue-in-cheek reasons. Precision Lender was and still is a Microsoft.NET shop. And so when I came in there, it was like, okay, the choice for language that we're going to use is either going to be C# or Python. And even though I'm a Python guy at heart, it made sense to do it in C# because that's what the company did. I went with what was already there. I'm like, okay, totally cool. So if
I think the constrictor name is good because you may have been a little constricted on the choices that you had, right? Little play there, right?
So we started building the project, and the way I approached it was to go lean. That's one of my software testing convictions. Add value as you go. And when it's like, okay, you already have this massive web application with all of these various parts and components, and it's been going for almost a decade, and you're now coming in starting to try to get some protection on there. It's like, oh geez, you got to go lean. So it's like, okay, we got spec flow in place at the time. Selenium WebDriver was still king. Cypress at that time was still like brand new, and it didn't support other browsers other than Chrome. And we're like, well, our banking customers use IE, so we can't do that. Playwright did not exist yet. So, okay, we're using Selenium WebDriver. So I got some basic tests, smoke tests. I got them running locally. I got them running overnight. And originally I was using page objects because okay, this is like bootstrapping, just get everything up and going. And after the first few dozen tests, I realized very quickly, just as I had realized at my previous job at LexisNexis, these page objects ain't gonna cut it. this ain't it. This sucks. So I was like, shoot, what's the alternative? I'd known about Screenplay pattern, and I wanted to use that, but there was no major .NET implementation, right? Serenity BDD is Java and JavaScript. Great. Also, another thing that I saw with the Serenity projects that kind of, I don't want to say it put me off, but just one thing that you have to recognize is that Serenity is a full comprehensive framework, right? It's not just Screenplay. It's you get the reporting, you get all the other things that come with it. And I was like, well, I don't necessarily want all the other things. I just want a Screenplay implementation that I can use, that I can pop into my own framework that I'm building. And so with that in mind, I was like, okay, well, it looks like, A, I'm going to need to make my own Screenplay pattern or Screenplay implementation in C#. And secondly, I want it so that anyone else in the .NET space could plug and play use it, right? So that they wouldn't have to throw out their old project and start over with Serenity.net that I would make or something like that. I wanted it so that okay, there would be just a NuGet package, a library that you just kind of stick in. And, now instead of making WebDriver calls directly, you're making Screenplay calls. And that was the vision for the project.
Yeah, I think that's really smart. And it's good that you had the opportunity and the kind of company that would allow you to do that, right? Because that's a big limiter in a lot of us in testing, especially is time, resources, and budget for it. And if you've got buy-in from leadership to allow you to build something like that, that's irreplaceable. And you see the difference that it makes immediately when you can start building things that other people use. That's pretty satisfying stuff.
Yep. And so it's funny because when it started, I did not start it with the intention explicitly of making it a standalone open source project. It was literally just like another package within our proprietary test automation project.
Sure.
We call it the BOA solution. Okay, solution because in .NET you have solutions and then projects. We had the BOA solution. And anyway, so it was literally just hanging out as a project within our solution. But I always had it in the back of my mind. It's I would eventually someday like for this to be released open source. The first time I had brought it up after it had attained a level of maturity, I hate to say it, my VP was kind of he said no without saying no. He was like, no, it's nice. No, I don't know. I'm
Where's the direct revenue? Yeah, right.
Yeah, that kind of thing. I'm just like, But then in 2020, it's funny. Our chief product officer came knocking on my door, and he had this vision for things. He wanted to pursue quote unquote radical transparency with the customers and wondering how we could leverage our testing practices and processes and stuff that we do for that. And I was like, here's my opportunity. Well, if you want to show our customers what we do, if you want to, pull back the curtain, show them inside the factory, one thing we could do is we could open source part of our test code. It's do it. I'm like, and so that was the gateway to, that was like a high level approval to say, okay, we can take this part of our project and release it as an open source project for others to be able to use and consume. And so
that has returns associated with it too, because then your company gets associated with that, and then you get more revenue with the company, which gets you more budget, and so on and so forth, right? So I think that's really smart. That's why I wanted you to go into that a little bit. I think that's really smart lessons for people who maybe haven't been involved in, high level test architectures or test leadership. That's the fight that it often goes unheard and unseen. And I think that's really important to bring to the community. So thanks for going a little bit in depth on that. I think that's awesome.
Yeah, and I mean, it's good for the company in that sense, right? It reveals things to the customers. It helps everything you mentioned with that. It also helps with talent and recruitment because, I mean, think about it. If you're a software engineer, whether you're a developer or a tester, whatever specific role you do, I categorize everybody. You're an engineer in the software space. If you can, it's one thing to tell people what you do. Like I can tell you, oh yeah, when I was at PL, I was software engineer and test. But when I can show you publicly what I've done, I can point to the GitHub repository and say, there's our open source project that my team and I put out. That's very powerful. That's like evidence. That's proof. And it shows like, hey, when you as an engineer inevitably go search for new opportunities, you can carry that with you and show, hey, this is what I've actually worked on. You can see our workmanship, our craft, and that is an enticement for companies to say, hey, we do support open source. We support our engineers on these projects because as an engineer, I would like to work for a company that does that. So I'm going to be attracted to companies that will have open source programs that I can contribute to because then it helps the company and it also helps me. So companies who do that will get better talent.
That's a really good point. And too, as somebody myself that's come up through testing from the ground up, you don't have to have a lot of those conversations on winning someone over on those concepts because coming into a company like that, it's already rooted. If they're embracing open source, that cat's out of the bag and there's no putting it back in at that point.
Exactly. It's a very cool thing.
and not common. So I do want to say that, this is it's a pretty cool thing and it's awesome to be a part of. And all that does is give you more energy into the next thing that you want to do. It gets addictive in a good way.
Yeah. And I mean, I will say I wouldn't say it was a fight to release boa constrictors open source, but it was a process. It was a journey, and it took a long time. It took a lot of work, and ultimately, like the way we did do it. First of all, there was that chief product officer, but also the company got bought out by a bigger company named Q2, and they had an open source initiative a few years prior that had started and then fallen flat. And so I was coming in there, and so I was kind of fighting through old processes, trying to get things jump started and reinvigorated again. So yeah, I mean, sometimes you might have to be the first one. Sometimes you might have to be bringing it back up again. Maybe you already have a highway that you can just drive right through. So all different experiences there.
Highway is a good one. Sometimes you just need a dump truck with reinforcements on the front. You just need to drive right over the barricades, right?
Mm-hmm. That's right, man. Get a ramp. Woo!
Cool. Great conversation. I think it definitely made me think, definitely made me see some different sides of things that I hadn't had time to look at in recent years. So thank you for bringing that. I think it's going to generate a lot of good buzz and get some more people looking at your open source offering there.
Cool, man. Glad to hear it.
Thanks a lot. Our next, so thank you again. So our next presenter, Matthias, he's going to be talking about security, basically how to do it, how to continuously do it through the testing process, and what it means to him. So Matthias, I believe you're ready to go if you could start sharing.
Yes, Chris, thank you very much. Let me share the screen. You can hear me properly?
Yes, and more importantly, am I pronouncing your name correctly?
Yes, everything was right.
Great.
So you should see the screen. You can see it, or?
Yes.
Yes, great. Sorry that I have to ask something because today I have quite a restricted technical setup.
No problem.
But I guess I'm fine to go. Good. Okay. Yeah. Also, hello from my side. Yeah. Thank you very much for having me here at this meetup. Yeah, powered by Zaptec. And yeah, as already mentioned by Chris, today I will talk about security testing, continuous security testing. So I will tackle this very often black box, which is called security testing. So, as an engineer, I always try to search for new solutions, and security actually is not really new, but it becomes more and more important. Yeah, just consider, yeah, we are. I mean, I don't know. Some years ago, we released once a quarter or once a month or whatever. Today, we frequently release, and yeah, several times per day. At least very mature companies, and therefore you need to have very, very good security testing approaches. I mean, if you check the newspaper or the news, you regularly hear some security issues where a company get yeah, a security bucket exploited and used. Recently, if I guess everyone knew this log4j issue, and of course you don't want to have that. Yeah, you don't want to have this bad reputation on the market. You don't want to lose tons of data, and of course you don't want to have this damage to your company, what is, by the way, not even countable. Just if you look at Meta and so on, if they have such security leaks, which they had several years ago. And today I will talk about SAS Dust, IAST, RASP. Yeah, I will mention that what this is, putting a DevSecOps teams on steroids, four fists and hallelujah. Here I used also a picture from a famous movie, at least here in Austria, Germany region. If you don't know them, no problem. Those two guys have weapons, and their weapons are their fists. They are very strong, and believe me, my fists here in the security area will be for sure as strong as those are from them. Before I dig into the topic, please let me also introduce myself a little bit. So who am I? I'm Matthias Zax. I am from Austria, yeah, so living there in the capital city, Vienna. And yeah, originally I'm a developer, and I shifted my mindset, or I upgraded myself, how I would say it, in the area of test automation about 3 years ago or something like this. So that you also know here in the background. Currently, I am working as an Agile engineering coach in the Raiffeisen Bank International. So what is an Agile engineering coach doing? It's nothing related to Scrum or Kanban or any Agile practices. It's more about, with this whole Agile transformation, engineering practices changed. And what I'm doing is training and coaching teams to get better there. For example, security testing, or personally, I'm more focused on test automation. So also what Andrew showed before, I really enjoyed the talk, especially coming from the technical part. Yeah, I like to share what we, also in RBI, I'm also the organizer at the community of practice there, so which is a strong internal community where we foster test automation topics. Up to now, we haven't published any open source frameworks, but maybe in the future. I like to speak on conferences, meetups, so I want to share, I want to contribute to the community, that I share what we are doing and that they can benefit out of that. Also to some magazines, so IT magazines mostly, of course. And if you want to get in contact with me, please use this contact data, preferable on LinkedIn. That's to me, but now come to this topic, security testing. So to the agenda. First, I will show you something about the motivation, why I went into this topic. Then I will explain you what is security testing, what is or how I would explain it. Then I will explain the hallelujah, and at the end I will show you 10 steps to success, how you can put your team on steroids with security testing. Motivation, what motivated me to go into this topic, and I also want to show you then some numbers which I found during my research. So let me give you some bullet points. Security testing, it was always something for me which was not, it was kind of a black box for me. Yeah, it was not tangible. I know it was important. I know it's here and we have to do it. We have to do this pen test, but always security was something which was very expensive, and it was always outsourced, and there was a company and we had to plan it a long time before in advance, and then they did something, we got the report, and that was the security testing for me, at least how I understood it. And at the end, security really slowed down the release cycle time. Release cycle time, yeah, so from the time where we kind of finished or where we committed our code to the time where the value was at the customer. So where it was deployed, so the customer was able to use it. And security, yeah, just if you consider if things are outsourced, it was really slowing this down. And as a developer, as a test automation engineer, as a automation practitioner. I want to automate things, and there must be a solution. I cannot accept it that I have wait for weeks until my software is deployable. And so I went into this topic, and I found some numbers, and they are quite interesting. So there were two companies doing research on security testing. There were companies were PurpleSec and SonicWall, and they published some numbers. And the first one is quite huge. It's about 90%. Yeah. And here we talk about 90% of all security incidents are due to attackers exploiting known software bugs. Yeah, so because maybe companies use outdated software libraries, for example, very old Java library or old web server or whatever, and the hackers, or however you want to call them, exploited those known software bugs, and that's 90%. That's crazy. Or we could avoid that by going for security testing, and of course, then also fixing the findings. The next number, 40%, and this is now a year-to-year comparison value from 2020 to 2021, we had a plus 40% of all to the malware attacks. And this curve is going very, very high. I'm quite sure this year we will have much more than 40%. So this means, and this is also because, computing power gets much, much, much more faster and cheaper. And hackers can use them and can attack systems very easily. And also it's quite easy because nowadays, with Dockerization and with everything, it's quite easy that you're attacking a system. You just download the Docker, and I don't want to explain that one. And the next number, this is also about 2020. It was 20 billion, and that was what their estimation was about. So approximately, of course, was the damage due to ransomware. And of course, I don't want to contribute to this value, or I don't want that my company contributes to this value, because that's already very high. And so we need to do something, especially with the first number. I don't want to that someone can exploit my system because I have a known software bug. So, but what is this security testing? What is continuous security testing? If we would sit now in person, I could ask you, and I'm quite sure if I ask 10 people, I will get kind of 11 different answers, because there are quite a lot of interpretations about that surrounding, and only a few people really go into the details and understand what security testing is. So let me give you my interpretation or my definition of security testing. That's quite an easy one. So security testing is, during security testing, vulnerabilities are discovered and attempts are made to exploit them. So that's quite straightforward. And also, if you know that, I guess you can also test like this against your system. And I distinguish it into three different types. The first type is the vulnerability assessment. So here you check your system, you scan it and analyze it. If you have some outdated software libraries, for example, for example, you use Java 1.8 or you use Log4j 1. something something, So this is that one. The next is penetration testing. I guess most of you know what penetration testing is. So here the system will be analyzed and attacked by this simulated malicious users. So the so-called pen testers, and they try to get access to it. For example, you have some website, you have cross-app scripting enabled, or any other techniques where you most probably can bypass a login or whatever. So this is penetration testing. And the next is compliance testing. Those are also known as conformity tests or regulatory tests. So, for example, I work for a banking environment, and of course, here are a lot of regulatories around or certifications. And for example, if you want to be PCI compliant, you need to test. They show you then some testing techniques, or also get external tested, of course. And this is also one area or one type of security testing. The next is, so we have these three areas, and now I want to show two groups because this is important. The first is this functional security tests. So for example, you have a login feature, yeah, and you want to test that the user management or the access right management is using as designed. Yeah, so if you log in, that you have only the rights which are really supposed to be as this user. Because also security testing is important if you get into the system, that you only see the data which is related to you. And for example, as a bank, I'm not allowed to see all the data. So also, if you're already in, you have to test here. And these tests can be, as I mentioned, login, logout, password policies, credential management, and so on. Yeah? So as understanding. And the other group is non-functional tests. I guess those are quite properly known. Here is OWASP, quite yeah, famous. So this is the Open Web Application Security Project. It's an, as I mentioned, open source community, and they are defining security risks and also what findings are outside, and you can regularly check there and use them. It's very, very powerful. And so for example, you could test a login feature with SQL injections. Yeah, this is quite probably what you most probably don't want to have, that someone is dropping a database through your email field or username field. And yeah, and also the compliance checks are in this group of non-functional security tests. So we have the three types and these two groups, and how we can get rid of these. Yeah, what we can do that we tested, that we can see if we have to go for more security testing and how we can go for that. And the answer is quite obvious. These are these four fists. Yeah. So SAST, DUST, IAST, and RASP. But what are those? And the first fist, SAST. So static application security testing. SAST is a white box testing approach. And so this means white box testing. So you need the source code, the bytecode, binary files, and so on. And you're testing if you have there some security issues. So these vulnerabilities are found very early in the SDLC, so the software development lifecycle. And this is also kind of shift left, yeah. So very early that you get these findings and you can fix it already in the development phase. So quite cheap then to fix them. There's kind of a drawback, so you cannot discover any runtime and environmental issues, but that's fine. The advantage is it's very, very fast, yeah, because scanning source code is much faster than having a running application and doing and checking there. But here we have another fist, which you will hear in a second. Tools I will not go into details here, but that you just heard them: SonarQube, TeamScale, also from OWASP, we have the dependency check tool, which are open source. TeamScale is a commercial software. So this is SAST, white box testing approach. The next is DUST, dynamic application security testing. We had right now white box. Now we have black box testing. So this is testing where you need your application running. So you need an environment, you need your application deployed there, and it needs to be running. So system under test. And here you can find vulnerabilities a little bit later in the SDLC, but still early. Yeah, in your dev environment, you can already test first things, but always consider most probably you have another environmental setup in your dev environment than in your production environment. Just that you consider that. And here are techniques used to do some fault injection techniques. For example, that you do SQL injections or JavaScript injections. If your system is secure here or not. Yeah? Tools are here, for example, OWASP, Purpsuit, or Gauntlet. And of course, I'm an engineer, so I have to show a little bit of tools or source code. And what I want to show you here is OWASP, because I want to make it a little bit more tangible, especially if you're completely new into this area. OWASP is, I mentioned, is from this open source community. It's a tool, so it's open source. They also support a Docker container, so you can download the Docker, you can run it, very, very easy. You can just insert here your URL. This is your application, and you run, for example, you don't configure anything else. You use the standard profile, everything else, and it will kind of attack your system. And afterwards, you get all the output. Yeah, of course, you need then to classify, and because at the beginning you will get really a lot, most probably, yeah, depending, of course. And then you get first insights. What are your security findings just from overstep? That's everything. Yeah, you can also integrate it, of course, in your pipeline. You don't need to use any UI. Yeah, everything can also run through command line. And then you have already implemented first security testing, continuous security testing. So quite easy. Or going back to the first. So we had SaaS Dust. The next is IAST, interactive application security testing. And IAST is quite cool because it combines the benefits of SAST and Dust. Yeah, it's kind of a combination of those both. And the biggest advantage is here that you have here less false positive. As I mentioned also before, if you do the dust checking, sometimes it happens that they have a false positive, so you have a finding, but it's not true, yeah, because it's on this environment we don't have it, or it was just a wrong finding. And IAST is much better here. So IAST addresses the shortcomings from SAST and Dust and combines both approaches. For the IaaS tools, you use the knowledge of the application flow, the data flow, to create advanced attack scenarios to use the results of the dynamic analysis. And yeah, as I mentioned, it reduces these false positive alarms or these false alarms, which is quite good. So you don't have to investigate to each finding, but you have to do on other techniques a little bit more. A drawback is, or a thing to do, you have or you need to install an agent. Yeah, it does not come out of the box. Something needs to be installed on the environment or attached to the application, which triggers and stores all the data which needs to be analyzed. And so it controls the runtime and data flow information. It also includes configuration information, also all the HTTP requests, responses which are happening, and also the libraries and frameworks which are used. And with that, you get a much better output. So during a dynamic scan, the tool learns based on the interaction to test cases information about the application. So the tool uses this knowledge to create additional test cases also at the end. What I mentioned before, it's also, you have your application, for example, your login, but you also want to get into the login and then scan your application more. Yeah? And then you get also more test cases. So for example, if you go to the login and then if you navigate to, I don't know, customer button, which customers are appeared there and so on, can I do their SQL injection? Because sometimes also, also an employee of a company is a potential security risk if you, take it precisely. A tool here, for example, what I want to mention is the Contrast Community Edition, which is also open source. So this is IaaS, a combination of SAST and Dust. So it combines black box and white box. And one is missing, which is also security testing. This is RASP. It's Runtime Application Security Protection. And this is rather, or not so much a security testing approach, it's more monitoring approach, but still it's very important because you want to know what is happening on your application and you want to see a potential attack. And here we use RASP as a technique. So RASP works inside an environment, and it's, as I mentioned, less a testing tool, it's more a security tool or protection tool. It gets plugged into your application, and it controls all your application flows and also the requests which are coming from which IP address and so on, and it screens those continuously. So it checks what is happening, and if something is malicious or seems not as designed, it can fire an alert, or it can even go that far that it terminates the session. For example, it blocks the IP address. So it closes the terminate session, it blocks the IP address, and you are fine for some time, which is very important. Tools are, for example, here also from OWASP, the App Sensor, And also the Contrast Community Edition serves here a RASP testing approach. Let me summarize the 4 fists, that we can, then I can show you how we use it. So SAST, it checks your code and dependencies. Dust, it checks your environment and the application. So black box, SAST, white box. IASP, it runs with your application and combines SAST and Dust. And RASP, it runs in the production or on your environment and verifies if you get attacked. So those are the 4 fists. And of course the hallelujah. So we want to use them. But before I show you how we use them or how we recommend to use them, I want to mention one very, very important thing. It's a little bit off topic, and in general, I don't do that, but it's really important. The most important competence about security testing is really the culture. It's about the people that they are trained, that they don't leave your netbook unlocked if you're working in the cafeteria or something like this. This is very, very important. So each of the roles in your team needs to be aware of security and do security testing. That's very important, and this was the reason I want to emphasize on that also here. And now I want to come back to kind of a little bit more technical, to the 4 fists and the pipeline. This is kind of this hallelujah. So how can a secure pipeline look like? So if I'm made raw now as a pipeline, so most of you know that one. Ooh, sorry, that was a misclick. So we have the secure design. So it's the first phase, coding, secure design phase, then secure coding, then continuous integration and deployment. Then we have the testing and production, or let's call it runtime defense. And this is the secure CI/CD pipeline. Easier. There is some white box, so there comes a little bit more. We have here on all these phases triggers, and to all these triggers we have activities. In the secure design phase, so where you're defining your user stories, where you sit together and do story refinement, you can do already here security testing. So what you can do threat modeling. So you draw your feature, use you show where is a potential security risk. So where your API calls are going, where is an external system, where you need to test most probably something. And here you can define already functional security tests. That's very important. Already in that phase, you have your user story and you test, that's the login, and I want to test if there is an SQL injection possible. Test case is designed, and if it comes to the development, you will test it, or you will even write a test automation case for that. Very important that you define security tests, functional or also maybe non-functional security tests. So this is in the design phase. Then we come to the coding, and here the triggers are, of course, the coding itself, but also code review. That you do the peering session, someone checks the code and looks with a critical eye on security issues or on the security findings. And of course, continuously. Why continuously? Because here comes the first fist into the game, and this is SAST. I mean, it's coding, white box testing approach. Here we have SAST. So the source code gets checked if we use some, for example, if you have your Gradle dependencies, if you use an outdated library and so on, or if you do a coding which is not security safe, it will already have here the findings. And of course, you want to fix them early, so you use IDE plugins, for example. You also can use SCA, would be maybe another fist. So SCA is a software composition analysis. So here you check all your dependencies. So for example, if you use JavaScript, as we heard before, and use NPM, if you add a framework which you use, you have the feeling you download the whole internet. So you use a lot of dependencies because they're dependent of each other, and it will check all of these dependency trees if you have there some security findings. That's SCA, just that you know that. Very briefly explained. The next phase, so we have coding, that's already secure, but then we build it, and so we have a package, so we have everything attached, and of course we want to deploy it. So and all those are triggers for a potential security issue. And here we come with the next fist into the game. Of course, we have again SAST because we have our artifact, and those binaries we can check again. It can happen that we have additional findings, and we have here dust. So we have our package, we deploy it, we run it on the dev environment or the integration environment, and we can do already our first overstep test, and we get first feedback. How does our application look like? And the most important stuff is what did change. Yeah. So of course, I don't want to implement any security issues. So here we have dust. Then we come to the testing phase. Of course, testing is an ongoing continuous activity through all phases, but here we talk about manual testing and the real testing activities. Here we come with the next one, and this is IAST. Yeah? So of course we have here also dust, especially if you're thinking about we go to the user acceptance environment. So if where manual testing is happening, we can check before also dust because you can automate that, the fast feedback. And IAST. Yeah, so you install your agent, you do your manual tests, or you do also your test automation tests with the IAST, and you get then this much better output from the IAST agent, from your IAST software. You can also execute here, and you should execute your function security test, which you have defined in the design phase. And you can here do already penetration testing. Yeah, so from overstep, that's not much more than also doing penetration tests. That you most probably, if you need this sign from the external company for the penetration tests, but maybe if you do all these things already internally, they maybe approve it just immediately. Yeah, or you will get much less findings from them, which is also awesome. And the last phase, obvious, I guess everyone knows it now. The trigger is kind of continuously. And what I want to have here is RASP. So I want to add here my monitor if I get attacked, and I want to have my graphs. I want to see what's ongoing, and also I want to destroy or terminate the one or the other session. Maybe at least I want to get an alert if something's happening, especially in the beginning. So this is the secure kind of this hallelujah, how you as a team, yeah, hopefully everyone has already a pipeline, and how you extend it. And now what I want to do as a ending, I want to give you 10 steps, what is kind of my prioritization I would recommend to do to get to this pipeline. The 10 steps to the hallelujah, the 10 steps to this continuous security testing approach to the secure pipeline. First is kind of team up. Yeah, I mentioned the culture aspect. So join forces if the security department. If you're an enterprise company, you for sure have a security department. If it requires more than upskill someone in your team to security testing. Yeah. Also, if you, join forces and in your team care about that you have security skills. Yeah. Very often this is not done. And then is this security testing is very often this black box, and this should not be. Yeah. Security testing is not that difficult. The next is then train your team in threat modeling. It's a very shift left approach. Yeah? So you draw on feature-based application page where threats can happen, and or where potential security risk is, and where I want to test. That's very transparent that the team is aware where we will test what. Introduce also misuse cases. Very often what I also see is that teams are really very good in defining test cases on this happy path, yeah, login successful, and maybe also login not successful with the error message text. They do the assertion there, but also introduce misuse cases that someone will hack your system. For example, you do a SQL injection test case, yeah, and you execute them. You write a test for that. So, and this could, of course, depending on the feature, the misuse case can be different. That you have them. And let's go. Yeah? Set up Dust, inclusive the IDE plugins, if they are available from the tool you choose, that you get the feedback very, very fast, especially from the SAST check, because that's quite an easy one. The next is that you go for Dust and add it as earliest as possible to your pipeline, that you get the output. Especially, I guess every one of us here has a running application of your product. We don't do it from scratch every day. That's happening very rarely. So you add SAST, you add Dust, and then you get the first outcome. You get the first matrix, And I would not go for any KPIs where you want to go for it. Yeah, for example, 0 major findings and 10 mid findings or whatever. I would say, okay, of course, maybe 0 major findings would be, or 0 critical findings, maybe it's a good approach. But then you say a positive trend, so that you don't add any security issues with each release. Yeah, so that you really say, okay, from now on we have 355 findings without classifications now, and you won't get worse. Maybe you also can say you only won't get better. It would be even better. The next, if you're at that stage already, then you go for IAST agent. So you install that one on your user acceptance test environment or on the testing environment, wherever you want it, and get the findings out of that. As I mentioned, combination of SAST and Task. Then you automate low-hanging fruits. This step is already quite late, as you mentioned, or as I see, but very often the automation happens later on. If you can afford it earlier, good. If not, here you should do it latest, that you automate low-hanging fruits for functional security tests, also non-functional security tests, if you have defined them, of course. And at the last step, I would recommend that you go for RASP, that you get more transparency from your production environments, what's ongoing there, especially with this security eye. Yeah. Good. That was it. Thank you very much for your attention. Hopefully, I could explain you this whole security testing a little bit more. Also, what continuous security testing is, what these 4 security testing approaches are, which I showed you, my 4 fists. Of course, there are much more outside, but those what I have chosen. And at least for us, it brought us much more insight from the application about security. And yeah, our products are much secure now. I mean, they always were, yeah, but now we can deploy it very fast. Good. Thank you very much for your attention. Now I'm open for questions, if there are one. So let me, now I'm here. Good. Quite difficult to work with one monitor, I have to say.
Yeah, I was doing the same juggle. I've got a vertical split going between a couple different screens. Yeah.
So now I'm here. Good, Chris. Are there any questions in the chat already?
I am not sure. Usually somebody else on the other end handles the questions that come in. I'm not seeing any yet.
I can see some. You mentioned SAST is best for shift left approach in testing. Would you say shift left makes more sense for UI API testing? I mean, I would not restrict it to UI API testing. I mean, of course, there most probably the highest security risk is happening, because those things, especially if you have an open API, yeah, so an API which is usable from outside, and the UI, I mean, yeah, that one, especially if you're have it published to the world of the internet, or also to your user group, this is how your application can be attacked. But I mean, if you go for SAST, yeah, so if you go for a white box testing approach, that your sources get scanned and your dependencies get scanned, I would not restrict it to UI and API testing. If you have a product for, I don't know, databases, or where a lot of transportation, so ETL jobs, so you have a data source and you export it to another data source. Of course, you also want that there is, I don't know, to the port, FTP port 22 happening something, putting a file there with some weird scripts, and your database get dropped on the other end or something. So I wouldn't restrict it, but from a risk perspective, of course, UI and API testing or applications have the highest or higher risks. That's would be my answer to that question. Good.
You have, I don't know if you have more questions. I can't see them on my end, but do you have, a lot of people, when they go to something like this, is a concept that they're new to or don't have a lot of experience with, they tend to go to tools. Is there a certain group of tools or open source tools that you use? I did see mentions to OWASP Obviously, that's the industry standard. But what else? What else? Yeah. Well, there you go. Somebody asked the same question. What else can you use for that type of thing?
Good. I guess the question was now, the previous one was about IAST. Okay, yeah, that one.
Yes.
What tool can be used? I mean, I mentioned the Contours Community Edition. To be honest, we didn't went for that because we were quite satisfied with the SAS checking and dust checking. So we didn't went for the IAST agent. But I would recommend that one because I really like open source solutions, and if you need an agent or something needs to be installed, and in general the security area, a lot of companies are selling their products, which is quite okay, of course, but it makes it more difficult to do the evaluation for that. So of course you can get these trials and so on, but for open source it's quite easy. So I would recommend that for IAST, I would only go for that one if you have already implemented SAST and DUST, because that's quite easy to go for. For SAST, you can go for SonarQube. For example, please, these are no recommendations. It's just what we used. You get into your findings very fast. I also was surprised, how much findings we had. Doesn't mean that all of those needs to be fixed immediately. Especially the minor ones, but the critical ones you should. And in general, you don't have so much critical findings. And also for dust, I mean, it was quite easy to do kind of very fast penetration testing with overstep. As I mentioned, it is open source. I can recommend those. I can recommend, by the way, all tools from OWASP. Also to check out their website. So if you Google OWASP, you will find their website, and they also show you the top 10 security risk and so on. It's a very, very good source. If you have a web application, and I guess most of the applications nowadays are web related, that you see what's ongoing there. So that's quite good to check it out there once a month or something like this, to go on their website and check the latest things which are ongoing. And also maybe that you go to the tools sector and check what tools they are offering.
I think that's a really good bit of advice, just in general, when you're doing research on what's available, when you need to cover a certain part of the application with testing, even outside of security, right? Is constantly being aware of what's in the marketplace and just being aware of what's out there. A lot of times you try something and you think you can't do it, and then a year later, somebody solved it. And then you can go find a tool to do that, whether it's paid or open source, right? So I think that's a really good point. The second question was, what do you feel makes a DAST tool effective? What do you look for in a DAST tool that's good?
I mean, in the dust tool, it verifies, or it checks what is what is possible against your application. So that's your URL input, so HTTP, and then your application. What is possible without having any credentials? So maybe I can get into the system. It tries really a lot of different attacks. You can, depending on the tool, of course. And this is very important, because those attacks are very easy to do by hackers. So if there is a you can get, for example, which application server is in use, which PHP version do you use. This is, if you don't restrict that, those information is available from the website, of course, with some tools or with some specific cores. And if the hacker gets this information already, so if you use, for example, I don't know, PHP 5, because just by accident I know that from a friend of mine, which has a friend, but not in our company, of course, no serious. And so if the hacker gets this information, of course, he can then Google, what are known software bugs on PHP 5.2, using Apache, I don't know, 2.2. And if it's really easy, maybe he also finds a Docker image where you already can use this software bugs and exploit them and use them. And that's very easy. I mean, or doing if your application behaves weird after, if you get a brute force attack, that of course you also don't have, so that I don't know, your time responses go dramatically up if you get, I don't know, 100 or 1,000 cores in a second, which is not so much, to be honest, depending on the application. And this makes Dust very effective because it checks your environment, it checks your application which is running, and at the end, this is the application which your user is using, and this is also your application which gets attractive for one or the other person which should not use your application. So hopefully you know what I mean. And
Yeah, I do.
yeah,
As a test professional, if I was going to think of how would I get into an application, right? Like looking at the different versions of the tech stack that are in use. If you know as a hacker that there are certain versions that have certain vulnerabilities, you're going to target those first, right? So I think that was a really good point that you brought up. You're looking at how to narrow any testing, right? Even if you're a hacker, you're testing, right? You're trying to eliminate all the different permutations and narrow down your test scope. So a hacker wants to do the same thing. They're no different. How do I find that? Well, how do I find known vulnerabilities? I go look for the versions, and then I can start to target my attacks based on what those vulnerabilities expose. So I think that was a really
absolutely
good point.
correct. Absolutely correct. And I mean, I guess everyone knew that. I mean, we are all working in the testing area, test automation area, or software area, and the Log4j issue which happened. I mean, that was crazy how fast hackers used that. Yeah, the bug got published, and it was, I don't know, 1 hour later you already could download a GitHub repository
Yeah,
and use things. I
we're
mean,
watching those bugs to protect our applications, but they're watching those bugs the same. It will probably with even more attention, right? We're busy building, so we're busy paying attention to features. They're busy hacking, so they're paying attention to exploits. So
yes, I
it's a
mean,
different set of tools, and I think that's bringing these type of tools that you talked about today to the fore, so that people are aware of them and that they maybe might take these back to their companies and advocate for this type of testing is huge, because security is still very much an afterthought in a lot of companies.
yeah, that's true. Yeah, and I don't know why. I mean, I know also for me, security was not the highest attractive thing I wanted to go into, to be honest. Yeah, my motivation come really because I really want to automate things. I don't want to do this again and again, and I really didn't understand why we have to do after each major release or after breaking change this external pen test. I was like, why? I mean, we did it once, so why we don't automate it and send the report
Exactly.
to the external vendor? And I mean, we did it already, or we don't, or that we do, I don't know, we have it integrated already in our cycle, yeah, that we have the security approval immediately, because I didn't understand that, and that was the reason why I went into the details. Of course, I understand it more because, of course, also their testing approaches evolve by time, because they know more and more bugs, and also the yeah, software is developing. We cannot put a hold button here, but we can do a lot of things. Yeah, or so in our side, and maybe also one answer to a question which I got last time, which that was like, is security testing only something for enterprises, or do I also need to do that on a startup? And security testing. This was a very good question. I really enjoyed that one because before I worked for RBI, I also worked in only for startups. And the answer is you have another risk. Yeah. So maybe your startup company is not that attractive than an enterprise bank. So you will get less attacks, but maybe your startup will get bigger and bigger. So I mean that's what we already aim for, and so your risk gets higher, and most probably you get attacked. And also, if you're a small startup and someone is interested, yeah, then you had a bad day. So security is for everyone. And also, to be honest, if you're a startup, you have less applications where you have to test against compared to an enterprise, yeah, because they have tons of applications, and of course their effort which is going into security is much higher than if you have, I don't know, I don't have any example of a startup company.
No, I know what you mean. It's directly analogous to the number of customers and the amount of money you have coming in. But
Yes.
I actually liked your answer on that, because usually when I try to suggest security testing, whether we do it ourselves or whether maybe we don't have the the resources or the budget to do it ourselves and we have to outsource it. Usually when I'm selling that idea, I like to ask, that's the question we get is, well, why do we need to do that? Well, can we get hacked? Number one, the answer is always yes. Number two, do you care about your data getting out? And the answer is always yes. Or your customers' data, even more, especially if you're in a regulated industry like healthcare and you're subject to even further punishments if that gets out. So that's to put it simply, the question and answer is, can you get hacked? And the answer is always yes. So therefore you should test for security, whether you have one user or 8 million, doesn't matter.
Yes, that's true. I mean, and that's a very, very important point that you mentioned. Yeah? You always can get hacked. Yeah, I mean, Meta is for sure investing millions of euros or dollars into security testing, but still, some from time to time, people can exploit some data from them. Yeah, and I'm quite sure they're also quite struggling because if you're in their data, yeah, is very sensitive. It's customer rated data, and yeah, their bad reputation on the market. If you check over the stocks, if they get hacked, it drops per 30% or something like this. So the damage is tremendously high, and you want to get known if you get hacked. That's also very important that you check your production environments. Of course, if you check Meta, they have millions of production environments, yeah, in their clouds, clustered everywhere. But still, um, you need to check it, yeah, and you need to see what's ongoing, and that the yeah worst case you will terminate the one or the other session. Better to terminate one session than having one session too much often. Yeah. The worst case is as a user you would have to do the login again, yeah, or write a support email address maybe. But better than having losing, I don't know, 3 million entries of customers data. Yeah.
Yeah, it's a battle of competing priorities, and once you illustrate to whoever the stakeholders are, usually the business, that's the trade-off. It makes it pretty easy to sell more testing and more security awareness, and getting more budget for that. So yeah, I think that's a really good point.
Yes. And we all want to go for the or we all aim the same goal, that we want to release several times a day. If you check on Amazon side, they do this 100 times a day or something like this. And it's important to do that without having continuous security testing. Yeah. Because at some point in time, also an employee or a developer is funny and
Yeah,
deploying a crazy feature which is bypassing the login or whatever. I mean,
right.
that's not possible. Yeah. So
Which
there
I
needs
have
to be this
seen.
safety net.
A lot of times. A lot of those hooks are built for people like myself and you who are testing, and then they get forgotten to be removed when we go to production. And now all of a sudden you have a back door that gives you complete wide open access to everything if you know how to get to it. And that's why a lot of vulnerabilities are from people scanning endpoints, right? And that's where you get to where you spoke about people looking for different versions. A lot of times that info endpoint gets left open, and you can see what's deployed, what the version of software is, what the versions of libraries are. If you're publishing that info and you don't turn it off, it's freely available. So, and again, though, going back to my point about dev hooks and test hooks, if you're not paying attention to that and disabling that or making it launch dark, that's a huge thing that I've seen. I've actually seen that go in production before, and we luckily realized it that day and turned it right off with a flag. But luckily, that's another design paradigm. We had feature flags so that we could do that. So that's another part of you get into modern development, and launching dark and doing blue-green deploys. It all ties in. I think that ties into security as well, because it protects you in times that something does go wrong. If you're getting a security attack and it's related to a certain feature, you can just go flip a Boolean flag in the database and it's off, and your access is off. So those type of things, obviously it's a different conversation for a different day, but I think it ties into some of what you're talking about here with people like yourself. Doing this type of testing can help correct and find these things before they ever occur. That's the thing. If you can find these, but that kind of goes to a point that somebody asked in the chat earlier about, does shift left only make sense for UI and API testing? Shift left is just a cool thing that sounds cool. It's really about testing all the time and knowing what to test when. I think that every type of test should be run on a regular cadence, and depending on your app, how much and how often is up to you. But I think security, you shouldn't save it to the end. A lot of times companies save security and load testing and performance testing until the very end of the process. Well, a lot of times it's too late. You can't fix it. You're shipping in a week. What are you going to do when you find a vulnerability at that point in security or in performance or both? Usually it's, well, we'll do a little thing, but it doesn't fix the thing, right? That's
Or
why you're smiling.
or you don't ship it at all, and you do it in the next sprint.
But that usually doesn't happen. Usually the cat's out of the bag. Marketing is on board. Everybody's ready to go, and it goes. And then you have to deal with some fallout, right?
That's true. Yeah. I mean, it's very important. Maybe that also I can share, because as I mentioned before, security was something, yeah, not tangible really, and now I have much more insights. I'm still not a security expert. Please don't expect that from me, but my awareness really increased about the risk. Yeah, and I also saw how easy it is to exploit system or to check system. Yeah, and also to how easy it is to get first findings about you. So if you go, as I mentioned, for SaaS task, yeah, and this is already a big achievement, yeah, for you personally. Yeah, that's also kind of shift left, because you have now the awareness. Yeah, so you know the risk, and then you maybe, or you will definitely think about it if you test the application, and if you don't go for all these techniques, but if you write a test automation code, or if you do the manual testing, you will consider it. Yeah, maybe you do an exploratory testing sessions before release with a security eye. Yeah, so that, hey guys, now we do this session. Yeah, we sit together, we test our application before release, and we will try to hack it. Yeah.
Yeah,
Also,
and being
that's
aware, I think awareness is the key word. It's just being aware. It doesn't mean that you, as the person who thought of it, is the one that has to do it. A lot of times, people will think of great ideas and then they stifle them down because, well, I don't have time, right? Or I don't have budget, or I don't have buy-in. But if you can keep that idea going and bring that to somebody and get awareness to it and then get buy-in, the rest will take care of itself. Because if you can make a case for this type of scenario before it happens instead of after, it's a lot easier to get the buy-in. Well, sometimes.
absolutely yes. And it helps if you show your product owner how to hack your system. Believe me.
Correct. That's what I mean. I talk to my team personally all the time about sometimes it's easier to ask for forgiveness than it is for permission. And a
That's
lot,
true.
because people don't understand the concepts you're trying to sell them. But if you can do a quick POC, even something like that, that's just lightweight, doesn't take you very long, but you put together kind of an end-to-end POC, or proof of concept, and then you show them, it hits them upside the face and they can't deny it anymore. Then they go, oh, wow, this is what you were talking about.
Very good approach. I
Yeah.
like that one.
Yeah, it sounds like you've done that already.
But of course, not in production.
Right. Right. That's the
You know,
next step. That's
it,
actually a
it,
really good point. A lot of people are moving to testing in production as well, and that's a huge thing. I got the benefit of being part of a company where we had testers that did test in production, and they would also help us test before we pushed to production. They were experts on what it should do, right? So they would help us as engineering testers catch some of that stuff that we didn't think of, because they're the people that are using it every day. So I think testing in production is a massive opportunity. And a lot of times you just don't have, again, time, budget, resources, or whatever stops you from being able to do it. But I think having that awareness, going back to that word that you used, is key, because at least you can try to move toward it.
absolutely true. Yeah. Really, this is also what I see quite often, that the product owner is aware that he needs to release very fast. Yeah, so we need to ship features at least every 2 weeks, yeah, to our customers, because they want it. Yeah, which is good. Yeah, and I want to ship every day if I could afford it. Yeah, but the awareness is not really here. I mean, don't get me wrong. Yeah, about the risk. Yeah, if we ship faster and faster and faster, what is the risk related to that? And of course, security is very highly related to the risk. And we should also create this as a test engineer. It's our responsibility to create this awareness for all our, let's call it now, stakeholders. And it's then quite good if you, I don't know, install or use a overstep dependency check, overstep, sorry, and just show them the report of all findings which we have on our UART environment from our application, just to make a picture. Yeah, it's easy to put them in Excel or whatever technology you have, or and make a beautiful graph with all the risks, all the findings. Sorry, with all the categories I wanted to say, and this is then visualized and people see it, and then okay, maybe we don't want to have any critical finding, and maybe we don't want to have any major findings where we don't have an answer for it. Yeah, so with that all of the team knows the major issues of the application and so on.
Yeah, and if you're using, Agile, which most shops either are or moving toward, you can make that part of your definition of done, right? You're not done a release or you're not done a story until it passes XYZ test. It's just another test. It's another type of test. That's all it is, right? It's just a different way to check that we've got things covered. The functionality usually gets tested very thoroughly, but the edge cases, the negative cases, the security, the pen testing, the performance and load testing, that stuff either doesn't get touched as much or not at all. So I think bringing awareness, again, you use that word and I know I'm pounding on it, but I think that's the big thing, is making people aware of the impact. If we don't do it, this is what happens. Everybody can tell the story of what happens once it happens, but telling people and warning before it happens is the key. And that's where you get some credibility and you can get more and more buy-in for things that you want to do in the future and do more cool stuff. So I think that was all the questions we had. I think that I haven't seen any more come in since we've been chatting. Did you have anything else you wanted to cover?
Not really. Yeah. If my contribution to the community is now that they are aware, of security and the risks, security testing and the risks, and I showed them maybe my approach, or our approach, how we deal with it. Please, that's not a silver bullet and not a blueprint. That's already great. So if I create that awareness, and if I maybe one or the other motivated to go into more details, also please, you can connect to me and we can have also chat afterwards. If you want to discuss the one or the other thing, I'm always open for that.
Yeah, definitely. Zappletech did a good job of sharing your information and Andrew's information on the event page. So it has your LinkedIn. So anybody that wants to talk to them, feel free to connect. I've already connected to Andrew. I've sent one to you already. I think it's been a great conversation today. Really good topics. It's nice to talk to people that are doing it, not just talking about it. And coming up with real solutions to these problems. So thank you very much for everything today. And I think this was a really good event, and I learned a lot myself too. So what else can you ask?
Awesome. Good. Then I would say thank you very much. Thank you very much for the very, very nice and kind moderation. And hopefully see you soon.
You too.
Bye-bye.
Thank you very much. Bye, everyone.